Have you ever thought about why it's important to know not just how fast you're moving, but also the direction you're heading? Whether it's a rocket launching into space or a ship sailing across the ocean, understanding the concepts of speed and velocity is essential to grasping motion. Welcome to Diara's Academy. Today, we're breaking down the differences between speed and velocity, a topic that's essential for mastering physics. Let's dive into the details. Let's start with speed. In physics, speed is a scalar quantity, which means it only tells us how fast something is moving, without considering the direction. It is defined as the distance traveled divided by the time it takes to travel that distance. For example, if a rocket travels 150 meters in 10 seconds, what is the speed of the rocket? Well, we can find the speed by dividing the distance traveled by the rocket, which is 150 meters, by the time, which is 10 seconds. Solving this equation gives us a speed of the rocket, which is 15 meters per second. Speed is all about the magnitude of movement. It tells you how fast something is moving, but not where it's heading. Now, let's talk about velocity. Unlike speed, velocity is a vector quantity, which means it includes both how fast something is moving and the direction in which it is moving. To calculate velocity, we use displacement, which is the straight line distance between the starting point and the ending point, divided by the time. For example, if a ship sails 200 kilometers north in 5 hours, what is the velocity of the ship? The velocity can be found by dividing the displacement, which is 200 kilometers in north, by the time, which is 5 hours. This gives us a velocity of 40 kilometers per hour in north direction. So, velocity gives us a complete picture of motion. It tells us both how fast an object is moving and in which direction. Let's clarify the differences between speed and velocity. Speed tells us how fast something is moving but does not take direction into account. It's a scalar quantity, whereas velocity includes both speed and direction. It's a vector quantity. Imagine a rocket launches 300 kilometers into space and then returns back to Earth, completing the round trip in 4 hours. To calculate the speed, we divide the total distance traveled by the rocket, which is 600 kilometers, by the total time of 4 hours. Solving this gives us 150 kilometers per hour. So, basically, we can say that rocket was moving at the speed of 150 kilometers per hour to complete the journey. However, velocity of the rocket is not 150 kilometers per hour because the rocket returns to its starting point, hence the displacement is 0. Dividing 0 by 4 hours gives us 0. Hence, the velocity of the rocket is 0. This shows that while speed and velocity might seem similar, they can give different results depending on the situation. Next, let's discuss instantaneous speed and velocity. Imagine a rocket shooting up into the sky. As it accelerates, we can measure how fast it's moving at any specific moment using a speedometer. This measurement is called instantaneous speed, which tells us the speed at that exact moment in time. For example, at one point, the speedometer might show that the rocket is moving at 200 meters per second, and a few seconds later, it might show 300 meters per second. Instantaneous velocity, on the other hand, also includes the direction. So if the rocket is moving 300 meters per second straight up, the instantaneous velocity would be 300 meters per second upwards. Now it's your turn. Let's solve a couple of practice problems to apply what we've learned. Problem 1. A cyclist travels 30 kilometers north in 1.5 hours. What is their speed and velocity? Problem 2. A rocket rises to a height of 200 meters in 8 seconds, then falls back to the ground in 8 seconds. What are its speed and velocity on the way up, the way down, and for the entire trip? Note: consider displacement carefully for each part of the journey. Pause the video, solve these problems, and when you're ready, let's go over the solutions. Let's review the solutions. Solution to problem 1. To find the cyclist's speed, we divide the distance, which is 30 kilometers, by the time, which is 1.5 hours. This gives us a speed of 20 kilometers per hour. For velocity, since the cyclist is traveling north, the velocity is 20 km per hour in north direction. Solution to problem 2. Now, let's break down the rocket's motion into 3 parts. 1. The upward motion, 2. The downward motion, and 3. The entire journey. On the way up, we find the speed by dividing the distance, 200 meters, by the time, 8 seconds. This gives us a speed of 25 meters per second. Since the rocket is moving upwards, the velocity is also 25 meters per second upwards. On the way down, the speed is still 25 meters per second because it travels the same distance in the same amount of time. However, the velocity is now 25 meters per second downwards because the direction has changed. For the entire trip, the displacement is 0 because the rocket returns to its starting point, the ground. Since velocity is calculated using displacement, the average velocity for the entire journey is 0. However, the speed remains 25 meters per second during both the upward and downward motions. This distinction between speed and velocity helps illustrate how they behave differently depending on the direction of movement and overall displacement. Mastering these concepts is key to understanding motion in physics. If you found this video helpful, don't forget to like, subscribe, and hit the notification bell for more insightful lessons from Diara's Academy. See you in the next video.